Welcome back to my YouTube channel. Make sure you hit that subscribe button and become part of the Becky Army. So that's the name of my community on TikTok, YouTube, and Instagram. So make sure you become part of that community. My community is just a great group of people, like-minded. I do vlogs, I'll have a podcast coming out. So make sure you subscribe so you get to see all of that new content that I'm making. But before we get into the video, I have to say that this topic today I feel like is going to bring a lot of value to all of you. And it's a topic that a lot of people can relate to. So I'll be looking at the psychobiological effects of stress. So we'll be discussing it. Look at the in-depth article that I've been reading, and we'll make a great discussion out of this. So I feel like this is a very helpful video. We're going to get started. Today's vlog is very interesting because it's looking at both the psychology and the biology aspect behind stress. It really begs the question about why should we be interested in stress? And if you think about it, stress is now part of our everyday lives. Technology has been advanced. There's so many aspects that have advanced that it's part of our daily lives, and it makes us who we are as humans. It's also part of the human condition. So that's why we should be interested in stress. We need to understand what it does to the body, and also looking at that aspect, we'll talk about it a little more in depth, of childhood. So having a childhood that was traumatic or dealing with stress early on, early childhood stress or the onset of stress at an early age also leads to those impacts as an adult. The interest in stress really started to date back to World War I. So a lot of soldiers would come back from the battlefield and they would be dealing with shell shock from what they had seen. So what they witnessed led to the shell shock, and that became a marker. So that also led to post-traumatic stress disorder. And over the years, after World War I, there was a growing interest. That's why it began to expand in the roles of psychology and biology. People became interested. It led to more funding, more research. So after that, that was the driver to bring these research topics about. Stress affects everyone, and that's why it became such a public awareness of having the research come out. More and more articles were written after World War I. It was because it's everywhere in our lives, in our daily lives, and it affects everybody. When you think about it, there's an autonomic and even a neuroendocrine response. Those hormones like cortisol. So cortisol levels get spiked, most likely in those morning hours. You see the highest levels of cortisol, kind of tapers down, and then by nighttime, cortisol levels tend to drop. So we'll be discussing different aspects of this. So there was a researcher in the field, his name is McEwen, from 1998, and he created the concept in terms of stress called an allostatic overload. Probably wondering what the hell is that? And an allostatic overload is the wear and tear that your body goes through after experiencing long-term stress. So this is repeated exposure of stress and the long-term effects. So this researcher in 1998 was looking at that. He found that there were so many systems that were impacting one another, and there were negative outcomes. There was a rise in obesity, cardiovascular issues, also hormone levels, cortisol was spiking. When you're dealing with stress, two systems get activated first, and the first one is the SMA, so that's your sympathetic adrenal medullary system, and the second one is the HPA axis. You've probably heard of it. So that's your hypothalamic adrenal pituitary axis. And think about this, when your body's under a lot of stress, it's going to release a surge of cortisol. That cortisol is normally going to break down the energy. So that energy is going to be stored in your muscles, the liver as glycogen, and that glycogen is going to get broken down into glucose. And the glucose is what your brain's going to utilize, things like that. So all that excess energy that's stored in the liver and the muscles as glycogen then gets broken down into glucose. If the body keeps experiencing stress after stress, you can see how that can have an effect. It keeps breaking down the body. So that was that allostatic overload I was talking about, the wear and tear. After a while, your body's going to feel the effects, and you're going to notice that. And cortisol is not only involved in stress, okay? There's other functions of cortisol. Cortisol is involved even in our regulating our circadian rhythm. And all the researchers looked at it, and we're talking about that allostatic overload, the wear and tear on the body. And they had found that stress may lead to tissue damage, so you can get tissue damage. There was calcification of the heart after about 3 years. So all of these things were having an effect on that HPA axis. There's another researcher named Hammer. He decided to run a study, and they found that it was after 3 years that there was coronary artery calcification. So when someone experienced stress, it took 3 years later, and then they were seeing that hardening of the calcification of their coronary systems. And not all stress is bad. You need a little stressors here and there. Sometimes it's to finish a deadline, so not all stress is bad. Some little stressors are fine, but we're talking about long-term exposure to stress. There's a lot of research that still needs to be done, but there's something called the cortisol awakening response. So when you wake up the first 30 to 45 minutes in your day, that's when your cortisol levels spike the most. So that's the highest levels of cortisol, and then it starts to taper down. And obviously by the nighttime, it is leveled off. The levels are very low. They're still trying to understand exactly how this system works. They call it CAR, C-A-R, and they also found that it's needed. So it helps us function throughout our day. So they theorized that, well, this system is needed in place. So we really do need this cortisol activation in the mornings to help us get through our days as humans. And other researchers even were looking at biomarkers from the scalp. So they were measuring how much stress somebody was under, and another biomarker to determine that was hair follicles. So there are glucocorticoids that were found in the hair samples. So they would take about a centimeter, and it was the ones closest to the scalp, and they could measure these cortisol levels by using hair samples. And they were trying to figure out, would the hair sample be a great indicator or a biomarker? And the researchers found out that the hair samples were doing a great job as an alternative method to look at the stress levels. And the researchers had found that cortisol levels could be determined with a 1 centimeter piece of hair the closest to the scalp. So that could give you a look at a month. So a month of stress levels. And if you did 3 centimeters, that would help you determine what's going on with someone's stress levels over a course of 3 months. So that was a very interesting study. That is a great biomarker. They're going to keep using that now, incorporating it into these stress studies, so your hair can be used as an indicator of stress. It really turned out to be a reliable indicator of stress that someone had undergone. So that was something that was a little different that they wanted to try out. They're like, hey, is this even reliable? And they found out that it was an effective marker of stress. And you look at the research, the stress long-term, because people short-term may think, oh, stress is nothing. But long-term, it really did create, you're looking at heart rate levels, you're looking at high blood pressure, somebody that is dealing with excess body weight. So all those things were contributing to these factors long-term wise. And now we have a broader indicator of the human genome, and we're looking at gene expression. How does stress affect gene expression? They also did a research there, and in the transcription of the genes, they found that socially isolated individuals and people who did not have a lot of social support, they underwent a lot of stress as well. So that's now looking at the human genome side of things. That's another area of research that they're looking into. There's a lot of great research out there about stress, but as any research, there are limitations. So part of the limitations I wanted to discuss were the markers of what is considered chronic stress or a stressful event. So that's something that they really talked about. So for one person's stress may not be someone else's. So it's very subjective what we consider stress. So when they're running these researchers, they're asking what stress someone is under. That's part of it. How do you really determine what is chronic stress? And everyone has different markers. So they realize that it is subjective. Your stress could be different than mine. So I love that they do talk about that, and there are limitations to these studies. When they were running these studies too, sometimes they would test students who were very stressed out psychologically before an exam, and they would find that the students that were not stressed about the exam, obviously they had lower cortisol levels than the ones that were super stressed. And these studies are so important because these are looking at chronic stress over a long-term period. These are not short-term, and it's breaking down the body. This allostatic overload, you're going to hear that term a lot with these stress studies, is how the wear and tear of the body does break down. So you're more susceptible to getting infectious diseases, you're more susceptible to getting sick, coming down with, let's say, stomach issues, so a host of other problems. And they also found that children that undergone stress at a young age, whether they witnessed domestic violence in their homes or had a very stressful childhood, they led to impulsive behavior in their adulthood. There's a host of other problems that go with this. I'm going to end right here with this quote. So one researcher said, "We shall never truly understand this phenomenon, since the complete comprehension of life is beyond the limits of the human mind." So there's only so far that you can understand stress. Like this researcher said, there's some things beyond the human mind, but it's so great to see the biology and psychology come together and that we're getting this research out there, and people are understanding that, you know, when they say don't sweat the small stuff, it's a reminder to sometimes do self-care and make sure that you prioritize your well-being.